Hello everyone, welcome to Learn Overflow. In this video, we'll discuss about a LeetCode problem that is the sort matrix diagonally. So this is the medium level problem and we'll understand what exactly the question is asking us to do and how easily we can solve a question like this. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. So the question tells us like a matrix diagonal is a diagonal line of cells starting from the sum cell in either topmost row or the topmost column and is going bottom right. Okay, it's going to the bottom right direction. So that's the direction bottom right. Okay, that's the direction it's going until reaching the matrix end. Fine. For example, the matrix diagonal starting from matrix 2 0, which has a matrix 6 cross 3, includes matrix 2 0 3 1 4 2. Fine. So that's the being saying like 2 0 being if it has a starting from 2 0, that is from something like here, it will go somewhere down the line. No, yeah. So that's the idea. So if it has a matrix, say 6 cross 3. Okay. Now, the question like that's the understanding of what is the matrix diagonal is. Okay, and then it says given an m cross n matrix, mat. So that's the mat given to us, fine. And we need to sort each diagonal in ascending order. Return the resulting matrix. Okay, so we need to sort the diagonals of the matrix in ascending order. Now, what would be our idea to move into the diagonals? Because we should traverse the travel the diagonal anyways, and then sort it, right? So that's the normal sorting idea. Now, what would be the idea over here? The idea can be like we need to explore the idea rather than directly like saying a solution to this idea. Why don't we explore it? Okay, so say there's a matrix over here. Fine, I'm just taking a matrix over here, a matrix of like say 4 cross 2 or something like that, right? So this is the matrix over here, right? This is the matrix for us. Now each of the diagonal will be something like this will be a diagonal, right? Similarly, this will be a diagonal. Okay, this will be a diagonal, and obviously a single unit is also considered as a diagonal. So that's the diagonal. Okay, so anyways, we need to find this diagonal. So we need to understand whether there are any like similarities between this conditions or like in is there anything we can directly find out? Because if we start reversing for the diagonals, we need to think like there can be multiple rows and columns, so the diagonals can end up having any length. Okay, like the length is not fixed for us. So what can happen? Let's see. Say this is the 0, this is 1. Okay, this is the I value is going on, and for the j value, this is 0, 1, 2, 3. Fine. So if we see, so the first box is 0 0. Fine. And for the from the first box, if we increase both I and j, okay, we can reach to this box. Okay, we are here, that is 0 0, and if we reach both I and j, that is 1 1, we reach to this box. So we understand that if both I and j are increased as a equal number, we can traverse in the diagonal. So that's the first idea. Okay, because 0 0, then the next diagonal box will be 1 1. Okay, so if we can do that, is it true for everything? Let's understand. So is the thing like if we look at this particular box, it's like 0 1, fine. And if we increase go by diagonal, it will be like 1 2. So we incremented I by 1, we incremented j by 1. So the idea is, see, the idea is if we need to traverse in a diagonal, like if we need to move in a diagonal format, we should increase our like this row and column by 1. Okay, both should be incremented at the same time. So that's when we will traverse in the diagonal statement. Now, once we understand this, that our traversal should be in a uh, diagonal manner, that means we should increment I and j at the same time with 1, like increment by 1. So can we find an idea from it? Can we tell like I minus j? Okay, so can we do something like I minus j? The other way is also true. So, but I mean, can we do I minus j? what becomes the answer? So if we do 0 minus 0 is like 0, fine. If we do 1 minus 1, that is 1 minus 1 is like in 0, fine. If we do 0 minus 1, that is minus 1. If we do 0 minus 2, that is minus 2. 0 minus 3 is minus 3. Then 1 minus 2 is minus 1. 1 minus 3 is minus 2. 1 minus 3. And here 1 minus 0 is 1. Okay. So if you do I minus j, or you can do the other way around, j minus 1 as well. So it doesn't matter actually. But look here, what we are trying to reach is like, if we do I minus j, then we at any position, if we are traversing our array from like just traversing our array row wise, then what happens, we directly know that if our I minus z is same, then we are at the diagonal, right? So we are at the diagonal because their I minus j value is going same. Is it an idea being coming up to us? Yes, it's an idea getting forecasted to us. Okay, so we are getting an idea that if our diagonal is remaining same, then we are simply going ahead with, fine. If a diagonal is remaining same, it's just incrementing as it is, fine. So that's the whole idea we have. Now after that, what will happen, we will we'll simply go ahead in that format. Now further what we can do, because we find that I minus j is an key to us, okay, so that's how we will traverse. Now for each of the I minus j, we will go ahead with storing something like a priority queue, okay, a priority queue, because that will help us in extracting the numbers in a like in a particular sorted order, right? Priority queue, if a normal priority queue will be like the smallest number, it will be a min hip one, so the smallest number will be in the top, so we can just traverse it and place the numbers as it. So what the idea is, the idea is, first we will traverse m cross n, okay, like a loop of I, like I loop, and that will go from 0 till length of length of mat, right, mat dot length. And then there will be a j loop that will run from 0 till mat of 0 dot length, fine. So that's the each of the row. So that's just ij loop will run, and for each of ij we will check what's the I minus j, and for each of the I minus j we will add a particular priority queue, okay. For each of the priority queue we'll keep adding this this particular value we have, the not this I minus j value, but the value in the matrix, that means the exact number being stored at that position of the matrix, okay, this numbers I mean, okay, the matrix numbers being given to us in our mat, okay, so we'll store them. Now once a priority queue is filled and once it traverses the whole matrix, next thing we'll do, we'll traverse it again, another impression loop, and in that we will simply keep popping the elements from the priority queue and keep placing them based on their I minus j position. Okay, so that's the whole idea. That's the basic idea we got in this. And if we talk about our complexity, the complexity would be like m cross n is like fixed complexity, and there will be the log n log of that I minus j, because the like the number of diagonals, the length of the diagonals. Okay, so that will be more like whoever is smaller. Okay, the minimum of m and n will be like log of m cross n. And then minimum of m and n. So that will be the, we'll understand this further once we have the code in front of us. So if I can, you can make understand what should be our approach in finding a solution to this kind of question. Like whenever they say like diagonal, we should think on finding something like I minus j. Like this is a I minus j is like our go-to with this cases. So let's quickly write down the code and then further explain how the code works in accordance with our concept that we just checked. Okay. So here it is. We find that this is a 13 millisecond solution, and this works well in finding a solution of us, like solution for us. We exactly now know that going through this particular method, we can reach a solution. But as you can see, this is not the fastest solution, and this is not the best solution we have because it has a high complexity. Fine. We are going through this in process again and again. We have this priority queue dot add, priority queue dot poll, which is again a login complexity. Fine. So obviously, if we think on it, we can definitely reduce the complexity. But for now, if we want to reach an answer to this, we know that we have an answer to this, right? So that's the idea over here. So that's the idea over here. So I hope I can make you understand how easily you can think on finding a solution to this kind of question. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.